So example 2a here deals with finding the value of a constant when we are told that the roots are equal. And in A it says, given the equation kx squared plus 12x plus k equals 0, where k is a positive constant, has equal roots, find the value of k. So given this equation has equal roots, find the value of k. So let's have a look at this. The equation is already in standard quadratic form. In other words, it's in the form ax squared plus bx plus c equals 0. This is because we only have one term in x squared and one term in x and in a constant. So we can write down the values of a, b, and c. A is the x squared coefficient, and that's going to be k. B is the x coefficient, which is 12, and c is the constant, which in this case is k. So c equals k. Now, we are told that the roots are equal, so we can immediately write down that delta must equal 0. And we know that delta is b squared minus 4ac. Now we can substitute in the values of a, b, and c. So b is 12, so b squared will be 12 squared. A, of course, is k, and c is also k. So times k here. And we can simplify this. So it's 144 minus 4k squared equals 0. Now we can solve for k in this equation. We can first take the 144 to the right-hand side. Now we can eliminate the negatives on both sides by dividing through by -1. And we can divide 4 into the right-hand side. And now we can take the square root on the right-hand side. Remember that when we take a square root on the right-hand side, it's always going to be plus or minus. And this we could work out on a calculator, but the square root of 144 is 12, and that of 4, of course, is 2. So we see that k has the value of plus or minus 6. Now, to go back to the question, it said k must be a positive constant. In other words, k will be positive 6 only. So k will equal 6 only. Then in B it says, calculate the values of k for which the equation x squared minus 3 equals 2kx plus 4k will have equal roots. This equation is clearly not in standard quadratic form, so we need to write it as such. And we're going to bring all the terms to the left-hand side. So x squared minus 2kx minus 3 minus 4k equals 0. Now the equation is in standard quadratic form because we have one term only in x squared and one term in x, and then the constant will be -3 minus 4k. Everything that doesn't have an x in it will be the constant. So we can write down the values of a, b, and c. A, of course, is the x squared coefficient, which is 1. B is the x coefficient, so it's -2k. In other words, everything next to x. So this will be b. And c is the constant, everything without an x in it. So in this case, c will be -3 minus 4k. Once again, we are told that the roots are equal, so we can start with delta equal to 0. So b squared minus 4ac will equal 0. Now we can substitute in the values of a, b, and c. So b squared will be negative 2k all squared. A is 1. And c is negative 3 minus 4k. We can simplify. So we get 4k squared when we square the negative 2k. Then a minus times a minus is a plus. And 4 times 3 is 12. Then we're going to get plus 4 times 4k is 16k. We can rearrange the terms. So we basically end up with a quadratic in k. We can simplify further by dividing through by 4. And now we can factorize. So k plus 3 times k plus 1 equals 0. And in solving for k, we see that k equals negative 3 or k equals negative 1. Then in C it says, for which values of p, where p is a constant, will the equation 2 minus p over x equals 1 over 2 minus x have equal roots? Now, we need to write this equation in standard quadratic form, and we can start by writing down, or rather getting rid of the fractions. So we're going to multiply through by the LCD, which is x into 2 minus x. So then 2 times x into 2 minus x is 2x into 2 minus x. Then x into the LCD, 2 minus x remains, times the numerator. So p multiplied by 2 minus x. On the right-hand side, 2 minus x into the LCD, x remains, times the numerator. So x times 1. We're going to multiply out on the left-hand side. So it's going to be 4x minus 2x squared minus 2p plus px. And I'm going to bring this x to the left-hand side as well. Now we can add like terms, and I'm going to rearrange the terms. I'm going to write first the term in x squared. Then 4x minus x is 3x. And then we also have plus px, and then minus 2p. This equation is not yet in standard quadratic form, because we have 2 terms in x, and we need to have 1 term in x only. So we can deal with this by taking out x as a common factor in these 2 terms. So it's going to be 3 plus p multiplied by x. So we're taking out x as a common factor here. Now the equation is in standard quadratic form. We have 1 term in x squared, 1 term in x, and in a constant. So we can write down the values of a, b, and c. So a, the x squared coefficient, is negative 2. B is the x coefficient. So that's 3 plus p. And c is the constant. So c equals negative 2p. Now, we are told that the roots are equal. So we can write down that delta equals 0. In other words, that b squared minus 4ac equals 0. So we can fill in the values of a, b, and c now. So b is 3 plus p. So we have 3 plus p all squared minus 4 times a times c. We're going to square out the brackets here. So the first term squared, this sign, then the first term times the second term times 2. So we're going to get 6p. and in the second term squared is p squared. So I'm basically using this expansion, a plus b squared is a squared plus 2ab plus b squared. This of course is 0, and we see that we have a quadratic here in p, and we can rearrange the terms. And now we can factorize. In fact, this is actually a perfect square. So we can square root the first term, then the middle term sign, and square root the third term, and it's all squared. And this is 0. So we see that p plus 3 squared must be 0. The only way that p plus 3 squared will be 0 is if p plus 3 is 0. Because then we will get 0 squared, which is 0. And we find then that the value of p is negative 3. Let's look at D. It says given k into 2x squared plus 1 equals x squared minus 2x, for which values of k will the equation have equal roots? Once again, we need to write this equation in standard quadratic form. So we're going to multiply out on the left-hand side. So it's 2kx squared plus k. And we're going to bring everything else to the left-hand side. So minus x squared plus 2x equals 0. It's still not in standard quadratic form because we have two terms in x squared. Now, I'm first going to write them next to each other. We're going to take out a common factor of x squared in the first two terms. So it's 2k minus 1 multiplied by x squared. Now the equation is in standard quadratic form because we have one term in x squared, one term in x, and then a constant. So writing down the values of a, b, and c, a is the x squared coefficient. In this case, it's 2k less 1. B is the x coefficient, which is 2. And c is the constant, which is k. Once again, we know that the roots are equal. So delta equals 0. We can plug in the values of a, b, and c. A, of course, is 2k minus 1. And c is this k. So then we have 4 minus, now 4 times k is 4k, times 2k is 8k squared. Then minus 4 times k is minus 4k, times negative 1 is plus 4k. I'm going to rearrange the terms. And once again, we have a quadratic in k. We're going to need to factorize this quadratic. So I want to get rid of the minus here. And I'm also going to divide through by 4. So basically, we're going to divide through by negative 4. So negative 8 divided by negative 4, of course, is positive 2. Then we'll have a minus here. 4 divided by 4 is 1. So just k and 1 here. Now, we need to solve this quadratic equation. So we can factorize. So just to check, we'll get 1k minus 2k will give us the minus k here. And in solving, we see that k is negative a half, or k is equal to 1. Then coming to E, it says if f of x equals 0 has roots x equals negative 5 plus or minus the square root of 3 minus 12k squared all over 4, for which values of k will the roots be equal? So in this case, we are given the roots, and they come to this, the right-hand side of this equation. We know that what's under the square root will always be delta. So we know that delta is equal to 3 minus 12k squared. So there's no need to work out delta in this case, because we already have delta under the square root. We also know that the roots are equal, so we can say that delta is equal to 0. In other words, that 3 minus 12k squared equals 0. And now we simply solve for k. We take the 3 across to the right-hand side. We can multiply through by negative 1, so these negatives will cancel. And now we can divide by 12 on the right-hand side. And of course, this is a quarter on the right-hand side. And finally, we can take the square root on the right-hand side. So k will equal plus or minus the square root of a quarter, which is plus or minus a half. So let's look at your answers to this question. In the first one it says, given this equation, for which values of m will the equation have equal roots? Now, this equation is already in standard quadratic form, so we can write down the values of a, b, and c. So a is the x squared coefficient, which is 2. B is the x coefficient, which is negative 6. And c is the constant, which is 5 minus m. Now, we are told that the roots must be equal, and that means that delta must equal 0. In other words, b squared minus 4ac must be equal to 0. And we substitute in the values of a, b, and c. So it's b squared, negative 6 squared, minus 4a, and a is 2, so 4ac, and c is 5 minus m. And this must be equal to 0. We can simplify, so it's 36 minus 8 times 5 is 40, and then minus 8 times minus m is plus 8m. So 36 minus 40, of course, is negative 4. And we simply solve for m. So 8m will equal positive 4. And m will equal 4 over 8, which is a half. So then the equation will have equal roots when m equals a half. Then in B it says, for which value of p, where p is a positive constant, will the equation px squared minus 3x equal p have equal roots? Now, we first have to write this equation in standard quadratic form, and we can do so by bringing the p to the left-hand side. Now we can write down the values of a, b, and c. A is the x squared coefficient, which is p. B is the x coefficient, which is negative 3. And c is the constant, so c will equal negative p. We know that for the roots to be equal, delta has to be equal to 0. So we plug in the values of a, b, and c. So b squared will be negative 3 squared minus 4a, and of course a is equal to p. So 4ac, and c is negative p. So this must be 0. We can simplify, so it's going to be 9. A minus times a minus here is a plus. 4 times p is 4p squared. Now we solve for p. We can divide by the 4 here. And we take the square root on the right hand side. So p is equal to plus or minus the square root of negative 9 over 4. Now, this is a non-real number. So non-real. In other words, the square root of a negative number is non-real. And this means that there's no real value of p for which the equation will have equal roots. So no real solution for p. Let's look at C. It says calculate the value of m for which the equation, and we are given this equation, will have equal roots. The equation is not in standard quadratic form, so we first have to write it as such. We're going to multiply into the brackets here. And we're also going to bring everything to the left-hand side. Now we can write down the values of a, b, and c. A is the x squared coefficient, which is 1. B is the x coefficient, which is negative m. And c consists of all the terms without an x in it. So c in this case will be negative m minus 1. Once again, we know that for the roots to be equal, delta has to be equal to 0. And we plug in the values of a, b, and c. So b squared will be negative m squared minus 4a, and a is 1. So 4a times c. And c, of course, is negative m minus 1. And this must be equal to 0. So we can multiply out. We get m squared. A minus times a minus here is a plus. So 4 times m here is 4m. And then negative 4 times negative 1 is positive 4. And this equals 0. Now we can factorize. This in fact is a perfect square. So we take the square root of the first term, the middle term sign, and the square root of the third term, which is 2. And this is all squared, and this must be 0. Then solving this equation, for m plus 2 squared to be 0, m plus 2 must be 0. Because only 0 squared will give us 0. And hence, we can find the value of m, and it comes to negative 2. Then coming to the last question here, it says, find a non-zero value of the constant m for which the equation, and we are given this equation, will have equal roots. The equation is not in standard quadratic form. And we can start by multiplying through by the LCD, which in this case is x into 1 minus x. So 1 minus x into the LCD, x remains times the numerator, so times 1. Then multiplying 1 by the LCD, we get x into 1 minus x. And x here into the LCD, 1 minus x remains, times the numerator. Now we can multiply out on the right hand side. And we can see that the x's cancel on both sides. We can now bring everything to the left-hand side. So bringing negative x squared across, we get positive x squared. And then I'm first going to write this term in x. So it's going to be minus mx. And then bring the negative m to the left-hand side, we get positive m. The equation is now in standard quadratic form. So we can write down the values of a, b, and c. A is 1, the x squared coefficient. B equals negative m. And c equals positive m. We know that for the roots to be equal, delta has to be equal to 0. So b squared will be minus m squared, or negative m squared, minus 4a times c. We can simplify this. We need to solve for m in this equation, and we can do so by taking out a common factor of m. In other words, we can factorize. Then, using the zero product rule, if m times m minus 4 is 0, that means that either m is 0 or m minus 4 is 0. And solving for m in this equation, we see that m is equal to 4. Now, we were told that we need to find a non-zero value of m, for which this equation will have equal roots. So we're going to exclude m equals 0 as an answer, and we're going to say that m equals 4 only. Example 2b here deals with finding the value of a constant when the roots of the equation are non-real. In A it says, for which values of k will the equation, and we are given this equation, have non-real roots. Now, the equation is already in standard quadratic form, so we can write down the values of a, b, and c. A, the x squared coefficient, equals k. B, the x coefficient, is negative 4. And c, the constant, is equal to 5. We know that for non-real roots, delta is going to be less than 0. In other words, b squared minus 4ac must be less than 0. We can plug in, so b squared will be negative 4 squared minus 4a times c, and this must be less than 0. Now we can simplify and solve for k. So 16 minus 20k will be less than 0. Minus 20k is going to be less than negative 16. And we divide by the negative 20 into the right-hand side. Now, because we're dividing by negative, the inequality will switch around. So we have negative 16 over negative 20. And we can simplify. A minus divided by a minus is a plus. And 4 into 16, 4 times. And into 25 times. So k will have to be greater than 4/5 or 0,8. Then in B it says, for which values of m will the equation 2x squared plus mx plus 2 equals 0 have non-real roots? Once again, the equation is in standard quadratic form. So we can write down the values of a, b, and c. A is going to be 2. B, the x coefficient, is going to be m. And c, the constant, is going to be 2. We know that the roots must be non-real, so delta will have to be less than 0. In other words, b squared minus 4ac must be less than 0. And we can plug in the values of a, b, and c. So m squared minus 4 times a times c must be less than 0. So we end up with m squared minus 4 times 2 is 8 times 2 is 16 is less than 0. This is a quadratic inequality, and it's also a difference of squares. So we can factorize this on the left-hand side as m minus 4 times m plus 4 being less than 0. We need to solve this inequality, so we're going to draw a graph, a parabola. So the roots of this parabola will be plus and minus 4. So negative 4 and positive 4. We want to know where m squared minus 16 is less than 0. In other words, where this graph is negative or below the x-axis. So we see that for values between plus and minus 4, in other words, for all these values of x, between negative and positive 4, the graph dips below the x-axis. In this case, of course, we're dealing with m and not x. So it may be better to write this as the m-axis. And we said for all values of m between negative and positive 4, the graph is negative or below the x-axis. So then our solution will be that m must be between negative 4 and positive 4. In other words, m must be greater than negative 4, but less than positive 4. Then coming to C, it says the solution of a quadratic equation is given as x equals 3 plus or minus the square root of 4 minus 8p all over 4, where p is an element of q. Now, q is a symbol used for the rational numbers, so p must be a rational number. Then it says determine the values of p so that the equation has non-real roots. Now, in this case, we are given the roots of a quadratic equation. And we know that this comes from the quadratic formula. So what's under the square root here will be delta. So there's no need to work out delta in this case. For non-real roots, we know that delta is less than 0. In other words, 4 minus 8p must be less than 0. And we can solve for p. So negative 8p must be less than negative 4. And we can divide the negative 8 into the right-hand side. And the inequality will switch around. So it's going to be p greater than negative 4 over negative 8. We can simplify. A minus divided by a minus is a plus. 4 into itself once and into 8 twice. So p is greater than a half. Now, we were told that p is an element of the rational numbers. So we have to include this in our answer. So p is greater than a half, and p is an element of the rational numbers. In other words, all rational numbers greater than a half will give the equation non-real roots. Let's look at the last question here. It says for which values of d will the equation x squared plus 2d equals 0 have non-real roots? Now, this equation is already in standard quadratic form, so we can write down the values of a, b, and c. A is the x squared coefficient, which is 1. There's no term in x in this equation, so b is going to be equal to 0. C is the term that doesn't contain any x's in it. In other words, the constant, so in this case c equals 2d. We know that the roots must be non-real, so delta will have to be less than 0. In other words, b squared minus 4ac must be less than 0. We can plug in the values of a, b, and c. So b squared will be 0 squared A is 1, and C is 2D. Now we simply solve for D in this inequality. So on the left-hand side, we have negative 4 times 2, which is negative 8. So negative 8D is less than 0. We can divide through by negative 8, and the inequality will switch around. So D will be greater than 0 divided by negative 8, of course, is 0. So our answer then is D must be greater than 0 for the roots to be non-real. So let's look at your answers to this question. In A it says, for which values of k will the equation, and we are given this equation, have no real roots? In other words, non-real roots. Now, the equation is already in standard form, so we can write down the values of A, B, and C. So A is the x squared coefficient, which is 1. B is the x coefficient, which is k, and C is the constant, which is 16. We know for non-real roots, delta is going to be less than 0. In other words, b squared minus 4ac is less than 0. And we can plug in the values of a, b, and c. So b squared will be k squared minus 4ac, so 4 times 1 times 16, so 64. We need to solve for k in this inequality, and it's a quadratic inequality, which is also a difference of squares. So we can factorize it as such. So it's going to be k minus 8 times k plus 8 less than 0. We want to solve for k here. So we're going to draw a rough sketch of a parabola. This should really be the k-axis, but it doesn't really matter because we are doing the sketch for our own purposes. So the roots are plus and minus 8. So positive and negative 8. We want to know where k squared minus 64 is less than 0 or negative. In other words, where this parabola is below the x-axis or negative. And we can see that it's negative for all values between positive and negative 8. So here dips below the x-axis. So all the values here for x, in other words for k really, where the graph is below the x-axis. And so our final answer here is going to be that k is greater than negative 8, but less than 8. Then coming to B, it says, for which values of p will this equation have non-real roots? We're going to bring the negative 5x to the left-hand side. So x squared plus 5x plus p is 0. Now we can write down the values of a, b, and c. So a is 1, the x squared coefficient. B is equal to 5. And c, the constant, is equal to p. Once again, delta will be less than 0. In other words, b squared minus 4ac is less than 0. And plugging in the values of a, b, and c, we have b squared, so 5 squared, which is 25, minus 4ac, so 4 times 1 times p. So 4p is less than 0. We want to solve for p in this inequality. So we can take the 25 to the right hand side. And now we can divide negative 4 into the right hand side. And because we are dividing by a negative number, the inequality will switch around. So we have p greater than negative 25 over negative 4. And in a minus divided by a minus is a plus. So p will be greater than 25 over 4. Then coming to c, it says the roots of a quadratic equation are given as, and here we are given the roots. Determine the values of m so that the roots are non-real. Now, we are given the roots in this case. And this, of course, comes from the quadratic formula. So we know that whatever is under the square root will be delta. So we can start by writing down that delta equals 16 minus 4m into negative m plus 5. And we can simplify this. So it's going to be 16 plus 4m squared minus 20m. And we can rewrite this in standard quadratic form as 4m squared minus 20m plus 16. Now, we know for non-real roots, delta is less than 0. In other words, 4m squared minus 20m plus 16 must be less than 0. We can simplify this by dividing through by 4. So m squared minus 5m plus 4 is less than 0. And this is a trinomial on the left-hand side, so we can factorize. We need to solve for m in this quadratic inequality. So we're going to draw a parabola. So we have the y-axis, and I'm going to use the m-axis here. The roots are positive and negative. Rather, the roots are positive 1 and positive 4. So let's draw the parabola. Once again, it's not to scale. Something like this. So positive 1 and positive 4. We want to know where this trinomial is negative. In other words, where the parabola is below the x-axis or negative. And we can see once again for this region, for all values of m between 1 and 4. So hence our solution will be that m is greater than 1, but less than 4. So in between 1 and 4. So all the values in between 1 and 4, or for all these values, the parabola is negative. Let's look at the last question here. It says given f of x equals x squared minus 5x plus 2, for which values of c will f of x equal to c have no real roots? So we're going to start by making f of x equal to c. So x squared minus 5x plus 2 equal to c. And we're going to bring the c to the left-hand side. And now we have the equation in standard quadratic form. So we can write down the values of a, b, and c. So a is 1, the x squared coefficient. B is the x coefficient, which is negative 5. And c is the constant, which is 2 minus c. Once again, we know that delta must be less than 0. So b squared minus 4ac must be less than 0. So b squared will be negative 5 squared, which is 25. A is 1. And c is 2 minus c. We need to solve for c here, so we're going to simplify. So negative 4 times 2 is negative 8. negative 4 times negative c is positive 4c. 25 minus 8 is 17, and we can take it to the other side as negative 17. And now we just divide by 4, or we divide 4 into the right-hand side. So c will be less than negative 17 over 4. Let's look at your answer to this additional question. We are given this quadratic equation where a and b are constants, and we are also told that this equation has no real roots. So the roots are non-real, and we need to show that this inequality holds. So let's have a look at it. Firstly, the equation is in standard quadratic form. So we can write down the values of a, b, and c. So a is the x squared coefficient, which is 1. B is the x coefficient, so negative 4a. And c is the constant, which is 2b plus 1. We know that the roots are non-real. So we know that delta is less than 0. So b squared will be negative 4a squared minus 4 times a times c. So this must be less than 0. We can simplify. So 16a squared. Then we have negative 4 times 2b, which is negative 8b, and negative 4 times positive 1, which is negative 4, is less than 0. Now, if you look at what we need to prove, we have b on the left-hand side. So we want to isolate b on the left-hand side. So we're going to take the 16a across as well as the negative 4. So we're going to get 4 minus 16a squared. Now we're going to divide through by negative a, or rather negative 8. Then our inequality will switch around. So we're going to get b greater than 4 divided by negative 8 is negative a half. Negative 16 divided by negative 8 is positive 2a squared. So negative 16a squared divided by negative 8 is positive 2a squared. Now, we need to manipulate the right-hand side to get it in this form. So, we're going to take out a half, and we're left with negative 1 plus 4a squared. A half times 4a squared will give 2a squared. Now, we're going to switch around the terms in the brackets here. And then we're going to factorize what's inside the brackets as a difference of squares. So we basically then have b greater than a half into 2a minus 1 times 2a plus 1. And let's have a look. It's in fact what we needed to get for the right-hand side of this inequality. So then we've shown that b is greater than a half into 2a minus 1 times 2a plus 1. So this example deals with finding the value of a constant when the roots of a quadratic equation are real. In A it says, find the values of the constant m for which the equation, so this equation, has two distinct real roots. Now, two distinct roots mean that the roots must be unequal. They have to be real, but they must be unequal. We know that when delta is equal to 0, the roots are both real and equal. However, in this case, the roots must be unequal. So we're going to use delta strictly greater than 0. But first we want to write this equation in standard quadratic form. So we're going to bring the 2 to the left-hand side. Now we can write down the values of a, b, and c. So a, the x squared coefficient is 1. B, the x coefficient is m plus 2. And c, the constant, is 3m minus 2. We said that the roots must be distinct but real. So delta must be strictly greater than 0. So we can plug in our values. So b squared will be m plus 2 all squared minus 4ac. So 4a, 4 times 1 times c. Strictly greater than 0. Now we can simplify, we can square out here. And here we can multiply out. We can add like terms. So 4m minus 12m is negative 8m, and 4 plus 8 is 12. We have a quadratic inequality in m, so we can factorize. We have to solve for m in this inequality. We can draw either a number line or we can draw a parabola. I'm going to draw a parabola in this case. So we have the m axis. Now the roots are positive 2 and positive 6. So we can draw a parabola. So positive 2 and positive 6. We want this quadratic to be greater than 0, in other words positive. And that's the same as the parabola being above the x-axis. So the question now is, for which m values will this parabola be above the m-axis? We can see that for m values greater than 6, it rises above the m-axis, and for m values less than 2, so all these m values, it rises above the m-axis. So then our solution will be m is less than 2, so all these values for m, or m is greater than 6. In other words, all these m values. In example B, it says, calculate the values of p for which the equation, so this equation, has real roots. There's an important difference between A and B. In A, in addition to the roots being real, they also had to be distinct or unequal. And we use delta strictly greater than 0. In B, the roots simply have to be real. In other words, there's no additional requirement that the roots must be unequal. So in B, we can use delta as greater than or equal to 0. So let's do that. We first want to write down the values of A, B, and C. So A is going to be 2p. B is going to be negative 4. And C, of course, is 3. And we said that delta can be greater than or equal to 0. So b squared minus 4ac must be greater than or equal to 0. So we can substitute in b squared will be negative 4 squared minus 4ac. So 4 times 2p times 3. Now we simply solve for p. Of course, negative 4 times 2 is negative 8 times 3 is negative 24. So negative 24p. And we can take the 16 to the right-hand side. Now we can divide negative 24 into the right-hand side. But because we are dividing by a negative number, the inequality switches around. And we can simplify. A minus divided by a minus is a plus. Then 8 into 26, or rather 8 into 16 twice, and into 24 thrice. So p is less than or equal to 2/3. Then coming to C, it says, determine the values of k for which the equation, so this equation, has two distinct real roots. So in addition to the roots having to be real, they also have to be distinct or unequal. So just like in A, we're going to use delta strictly greater than 0. Let's first write on A, B, and C. So A is equal to 2. B, the x coefficient, equals k plus 2. And C, the constant, equals k. And we said we're going to use delta strictly greater than 0. So then b squared will be k plus 2 squared minus 4ac. This is greater than 0. We can square out here. We can also multiply out here. And now we can use or add like terms. So 4k less 8k is negative 4k. Once again, we have a quadratic inequality, and this also happens to be a perfect square. So when we factorize this, it's going to be k minus 2 all squared greater than 0. We need to solve for k in this inequality. We know that the left-hand side of the inequality is a perfect square, which is always either going to be 0 or it's going to be positive. We want it to be strictly positive, in other words, strictly greater than 0. We don't want this to be equal to 0. We know that k minus 2 all squared is equal to 0 when k is equal to 2. So then, for any other value of k, so for any value of k other than 2, when we square the left-hand side, it's going to be positive, which is what we want, strictly greater than 0. So k is an element of real numbers, but k cannot equal 2. So just to reiterate, when k is 2, we get 0 on the left-hand side. But we want the left-hand side to be strictly positive, in other words, not equal to 0. And hence we exclude the value of k equal to 2. Any value other than 2 that we substitute in for k will make the left-hand side positive because we're squaring it. Let's look at the last question here. It says, given the quadratic equation, and we're given this equation, for which values of r will the equation have real roots? So here we don't have the additional requirement that the roots must be distinct or unequal. So we're going to use delta greater than or equal to 0. We first want to write down the values of a, b, and c. A is equal to r, that's the x squared coefficient. Then b is equal to 3, the x coefficient. And c is equal to negative r. And as we said, we're going to use delta greater than or equal to 0. So b squared then minus 4ac is greater than or equal to 0. B squared will be 3 squared, which is 9, minus 4ac. We can simplify the left-hand side here. A minus times a minus is a plus, so we get 4r squared. We need to solve for r in this inequality. In other words, we want to find the values of r that when we plug it into the left-hand side here, we're going to get an answer of that's either greater than 0 or equal to 0. Now, if you look carefully at the left-hand side here, 9 is a positive number, and 4r squared is a perfect square, which is always positive. So we're going to get a positive plus a positive, which is a positive. Of course, when r is 0, 4r squared will be 0, and 9 plus 0 is 9, which is still greater than 0. So no matter which value we plug in for r, whether it's negative or positive or 0, the left-hand side here will always be positive. And hence we're going to say that r is an element of real numbers. So any real number that we plug in for r will make the left-hand side positive. So let's look at your answers to this question. In A it says calculate the values of m for which the equation, so this equation, has real roots. Now, there's no requirement that the roots must be distinct or unequal. So we're going to use delta greater than or equal to 0. But first to write down the values of a, b, and c. A, the x squared coefficient, equals m. Then b, the x coefficient, is negative 5. And c, the constant, is equal to 2. And we said that we're going to use delta greater than or equal to 0. So b squared minus 4ac must be greater than or equal to 0. We can plug in, so minus 5 squared minus 4 times a, and a of course is m, times c, greater than and equal to 0, or greater than or equal to 0. So this is 25 minus 8m, greater than or equal to 0. We can solve for m. When we divide the negative 8 into the right-hand side, the inequality will switch around. So m less than or equal to. We can simplify the right-hand side. So m is less than or equal to. A negative divided by a negative is a positive. So m is less than or equal to 25 over 8. Then coming to b, it says the following quadratic equation, where m is a constant, has two distinct real roots. And we are given this equation. We are also told that x is an element of real numbers. That just means that the roots are real. Determine the range of the possible values of m. Now, in this case, we are told that the roots are distinct, in other words, unequal. So we know that for real roots that are unequal, delta is strictly greater than 0. So that's what we're going to use here. Then to write down the values of a, b, and c, a is equal to 1, B, the x coefficient, is equal to m plus 2. And C, the constant, is 4m minus 7. And we want distinct real roots, so delta is strictly greater than 0. So then b squared minus 4ac is greater than 0. Then to plug in, we have b squared, so m plus 2 all squared, minus 4 times a times c. This is greater than 0. Now we can simplify. We can square out the brackets here. We can multiply the negative 4 into the brackets. We can add like terms. So 4m less 16m is negative 12m, and 4 plus 28 is 32. We have a quadratic inequality, so we can factorize. We need to solve for m in this inequality, and we're going to draw a parabola in order to do that. So we're going to use an m-axis in this case. And our roots, of course, are 2 and 8. So positive 2 and positive 8. So let's draw the parabola. So this is not to scale. So 2 and 8. We want this quadratic to be positive, greater than 0. So we need the parabola to be above the x-axis, or in this case the m-axis. And we can see that to the right of 8, the parabola rises above the m-axis, and also to the left of 2. So then our final answer is going to be m is less than 2, or m is greater than 8. Let's look at C. It says determine the values of p for which the equation, so this equation, has 2 distinct real roots. Once again, the roots must be distinct or unequal, so we're going to use delta strictly greater than 0. So then the values of a, b, and c, a is equal to 3, b, the x coefficient, is p plus 3, and c, the constant, is equal to p. And we said that we're going to use delta strictly greater than 0. So in other words, b squared minus 4ac greater than 0. Now we can plug in. So p plus 3 all squared minus 4ac. We can simplify the left-hand side of this inequality by squaring out here. So p squared plus 6p plus 9. And we can multiply out here. So negative 12p greater than 0. We can add like terms. So we have a quadratic inequality in p. And this is also a perfect square. So we can factorize it as p minus 3 all squared. So the square root of the first term, the middle term sign, and the square root of the third term all squared. We need to find values of p such that when we plug it in here into the left-hand side, we get strictly greater than 0. We know that when p is equal to 3, the left-hand side is equal to 0. 3 minus 3 is 0 squared, which is 0. We want the left-hand side to be strictly greater than 0. We know that a perfect square will always be positive or 0. So hence, P is going to be an element of real numbers. So any real number except 3. So P is an element of real numbers, but P cannot be 3. Because when we plug 3 into here, the left-hand side is going to be equal to 0. And we want it to be strictly greater than 0. Let's look at the last question here. We are given this quadratic equation, and it says, for which values of P will the equation have real roots? So we don't have the requirement that the roots must be distinct or unequal, and hence we're going to use delta greater than or equal to 0. Then to write down the values of A, B, and C, A, the x squared coefficient, is P. B, the x coefficient, is 6. And C, the constant, is negative P. We said that we're going to use delta greater than or equal to 0. So greater than or equal to 0. So B squared minus 4AC greater than or equal to 0. B is equal to 6, so 6 squared is 36. A is P, and C, of course, is negative P. So then to simplify, we have negative 4P times negative P, which is positive 4P squared. This must be greater than or equal to 0. We need to find values of P such that when we plug it into the left-hand side, we get either equal to 0 or we get an answer that's greater than 0. Now, 4P squared is a perfect square, so it's always going to be either 0 or positive. Then when we add it to 36, which is a positive number, we're going to get a positive answer. So then any value of P, when plugged in here, whether negative or positive or 0, will make the left-hand side of this inequality positive. And hence P is an element of real numbers. This example deals with finding the value of a constant when a quadratic equation has rational roots. It says calculate the values of P for which the equation, so this equation, has real roots. Hence, find one value for P for which the roots will be real and rational. So there are two parts to this question. In the first part, we must find the values of P which will make the roots real, the roots of this equation. So let's do that. We can start by writing down the values of A, B, and C. So A is equal to 2P. B, the x coefficient, is negative 3. And C, the constant, is equal to 3. We know for real roots, delta has to be greater than or equal to 0. Let's first work out delta. It's going to be B squared minus 4 times A times C. And this is 9. Negative 4 times 2 is negative 8 times 3 is negative 24. So negative 24P. So delta is equal to 9 minus 24P. Now, as we said, for real roots, delta must be greater than or equal to 0. So 9 minus 24P must be greater than or equal to 0. We can solve for P. We can divide the negative 24 into the right-hand side. And of course, the inequality will switch around. So it will be P less than or equal to. Then a minus divided by a minus is a plus. So it's positive 9 over 24. This we can simplify. 3 into 9 thrice, and into 24 8 times. So p is less than or equal to 3 over 8. So, in other words, for the roots to be real, p must be less than or equal to 3 over 8. Let's now go to the second part of this question. It says, hence, find one value for p for which the roots will be real and rational. We know that for rational roots, delta must be a perfect square. In other words, 9 minus 24p must be a perfect square. We're going to do this by inspection. We already know that p must be less than or equal to 3 over 8. So we're looking for a value of p which is less than or equal to 3 over 8, that when we substitute it in, or into 9 minus 24p, which is delta, when we plug it into here, we get a perfect square. So let's try 3 over 8. So we want to see whether when we plug 3 over 8 in for p into this equation, whether we get a perfect square. So when p is equal to 3 over 8, delta, now delta is 9 minus 24p, so delta will equal 9 minus 24 times 3 over 8. And this is actually equal to 0. So we see that when p is 3 over 8, delta is equal to 0. And 0, of course, is also a perfect square. So the p value 3 over 8 does work. So the roots will be rational. So the roots are rational for p equal to 3 over 8. So this is one value of p which would work. Let's look at your answers to this question. In A it says, given the equation, so this equation, where k isn't equal to 5 over 2, find an integer k for which the roots will be rational and unequal. First, we can write this equation in standard quadratic form, and we can do so by cross-multiplying. I'm going to write k as k over 1. Then we're going to cross-multiply in this way. So then 1 times x squared minus 4 equals k times 2x minus 5, which is 2kx minus 5k. So just cross-multiplying. We can bring all our terms to one side, to the left-hand side, and also write it in standard quadratic form. So negative 5k to the left-hand side. The equation is now in standard quadratic form. So we can write down the values of a, b, and c. So a is 1, b is negative 2k, and c, the constant, is 5k minus 4. Once again, we're going to answer this question in two parts. Remember it said the roots must be rational and unequal. So let's first deal with the unequal part. For the roots to be unequal, they have to exist. In other words, delta would have to be strictly greater than 0. So let's do that. Delta must be strictly greater than 0 for the roots to be real and unequal. So now we can substitute in b squared minus 4a times c. This must be greater than 0. So we can simplify. We can multiply out here. We can also divide through by 4 to simplify this quadratic inequality with. So k squared minus 5k plus 4 greater than 0. We can factorize we're going to use a parabola in order to solve this quadratic inequality with. The roots, of course, are positive 1 and positive 4. So just a rough sketch of the parabola. I'm going to use a k-axis here. And as we said, the roots are 1 and 4. So 1 and 4. We want this quadratic inequality, or the left-hand side of it, to be greater than 0. In other words, positive. So that means we are looking for k values where the parabola is above the k-axis or positive. We can see to the right of 4, the parabola rises above the k-axis, as well as to the left of 1. So then our solution will be k is less than 1 or k is greater than 4. What does this answer represent? It represents the values of k for which the roots will be real and unequal, because we got it by solving delta strictly greater than 0. Now we need to look at the second part of this question. We also want the roots to be rational. And it says, find an integer k for which the roots will be rational. Now, we know that for rational roots, delta must be a perfect square. Okay, so this is a simplified form of delta over here. We want this to be a perfect square. And we must find one value for k, or of k, that will make this a perfect square. And we can do this by inspection. We know that k must be either less than 1 or greater than 4. So let's try a number greater than 4, an integer greater than 4. Let's try 5. Let's see if when we put 5 in for k, whether we get a perfect square. So k squared will be 5 squared times 4. 25 times 4 is 100. Minus 20 times 5, which is 100. So 100 minus 100 is 0, plus 16. So we see that when we plug in k equal to 5 into this left-hand side here, into delta, so this is delta, then we get 16, which is a perfect square. So k is equal to 5 does work. So we can just write this down. When k is 5, delta is 4 times k squared, so 4 times 5 squared, minus 20 times 5, and then plus 16. And this is 100 minus 100 plus 16, which is 16. In other words, when k is 5, delta is a perfect square. So k equal to 5 does work. Delta is a perfect square, and hence the roots are rational for k equal to 5. Of course, there are many other numbers other than 5 that would work as well. For example, we could have taken k less than 1. We could have taken k equal to 0. 0 is also a rational number. And when we put 0 in here, we get delta 16, which is a perfect square as well. So k equal to 0 would have worked as well. But we only needed to get one value of k one integral value of k that would make the roots rational. Let's look at B. It says given the equation, so this equation here, where c is greater than -2 but less than 5, give two values of c for which the roots of the equation are unequal and rational. Now, this is also a quadratic equation, and we can write down the values of a, b, and c. So a, the x squared coefficient, is 1. There's no term in x here, so b is 0. And of course c, the constant, is equal to c. Let's find delta. So b squared minus 4ac. So we see that delta comes to -4c. Now, once again, we're going to do this in two parts. Let's first deal with the unequal part. For the roots to be unequal, they must exist. In other words, the roots must be real. And delta will have to be strictly greater than 0. So delta is strictly greater than 0. And -4c must be greater than 0. Then we can divide the -4 into the right-hand side. So the inequality switches around. So c is going to be less than 0 divided by -4 is 0. So we see that for the roots to be real and unequal, c must be less than 0. We have an additional constraint on c. c must be between -2 and 5. So combining this inequality with this one here, we see that c would have to be greater than -2, but less than 0. So we're combining this inequality, c less than 0, with this one. So c would have to be greater than -2, but less than 0 for the roots to be real and unequal. Let's now deal with the second part, which is the rational part. For the roots to be rational, delta must be a perfect square. And we want to find a value of c, or two values of c, which will make delta here a perfect square. But bearing in mind that c must be greater than -2, but less than 0. Now, we can try and find two numbers between -2 and 0 that will, when we plug it in here, will make delta a perfect square. If I take -1, for example, -1 does lie between -2 and 0. And if I plug it in here, I'm going to get -4 times -1, which is +4, which is a perfect square. So one answer would be for c equal to -1. Let's think of another value of c that when we plug it in here, we get a perfect square. But the number, of course, must lie between -2 and 0. Such a number would be -1/4. If I put in -1/4 here, I get -4 times -1/4, which is 1, which is also a perfect square. So c will equal -1, and c equal -1/4 also works. So when c is -1 or -1/4, delta is a perfect square, and hence the roots are rational. Let's look at the last question here. So in C it says the equation, so this equation has real roots. And in part 1, it says find the greatest value of k such that k is an element of integers. So k has to be an integer. And we are told that the roots are real. Let's first write this equation in standard quadratic form. We can bring all our terms to the left-hand side. Now, for this equation to be in standard form, we need only one term in x squared. So we can achieve this by taking out x squared from these two terms. So we want only one term in x squared. Then we already have one term in x, and then the constant. Now we are told that the roots must be real. The roots must be real. So we know that delta must be greater than or equal to 0. Let's first write down a, b, and c. So a is 1 minus 3k. B is equal to 12. And c, the constant, is equal to -2. So for real roots, delta must be greater than or equal to 0. So b squared minus 4 times a times c must be greater than or equal to 0. We can simplify this. So -2 times -4 times -2 is positive 8. And we can multiply the positive 8 into the brackets here. Now we can solve for k. So 144 plus 8. We can divide the -24 into the right-hand side, and the inequality will switch around. So less than or equal to 152. A minus divided by a minus, of course, is a plus. So 152 divided by 24. We can work out, correct to 2 decimal places, what this comes to. It's 6,33. So k is less than or equal to 6,33. So we've answered the first part of the question. We needed to find the greatest value of k such that k is an element of integers. Now we get k is less than or equal to 6,33. So the largest integer just less than 6,33 is of course 6. So k will equal 6 in this case. So this is the largest integral value of k, which will make the roots real. Let's now look at the second part of this question, and it says find one rational value of k for which the above equation has rational roots. Now, we know for rational roots, delta has to be a perfect square, and we already have a simplified version of delta from part 1 of the question. So this here is a simplified version of delta, 152 minus 24k. So let's write that down. So delta equals 152 minus 24k. And we want delta to be a perfect square. Now, let's think of a perfect square close to 152, like 144. If we can let delta equal 144, it will be a perfect square, and the roots will be rational. So we simply make 152 minus 24k equal to 144. And we can solve for k. So 144 minus 152 is -8. And solving for k, -8 over -24. And we can simplify this. A minus times, or rather a minus divided by a minus is a plus. 8 into itself once, and into 24 thrice. So when k is equal to 1 over 3, which is a rational number, then delta will equal 144, which is a perfect square, and hence the roots are rational.